All right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So today I want to do a quick problem on Cartesian equations based off of when you have like x equals a t function, y equals a t function, so we call them parametrics. And this particular one is really interesting, so I thought I would share this one with you. It's x equals -6 cosine hyperbolic t, y equals 6 sine hyperbolic of t. And t goes from -infinity to infinity. I don't know if that's meant to throw you off or not, but that's really not that big of a deal, as you'll see in a second. But I'll show you how to figure out what this graph looks like without even needing to do this. But what we're going to do is we're going to take the equations, and we need to write them in terms of just x and y. Now, normally what you would do is you would solve for t and then kind of plug that in. The other one, kind of do a substitution method. But on this one, we're not really going to be able to do that because hyperbolics, cosine hyperbolic, right, cosine hyperbolic of t would be equal to e to the t power minus e to the negative t power over 2. Well, that's not going to be that easy to solve for t. We could also try to write it as e to the t plus e to the negative t. That might be another idea you have, to write it as sine hyperbolic. But usually when you're trying to get cosine and sine hyperbolics to go together, what you want to do is you want to use this little identity. And it's one of the Pythagorean identities for hyperbolics, and that's cosine hyperbolic squared t minus sine hyperbolic squared t is equal to 1. Kind of like the original, which is cosine squared t plus sine squared t equals 1. Just like it's basically like Pythagorean theorem. But this is this version. So what we need to do is we need to kind of make it look like that. If we can make it look like cosine hyperbolic and sine hyperbolic, then we're good to go here. So then what I do is I'll say, okay, well, let's square both sides. So x squared equals 36, -6 squared is 36, cosine hyperbolic squared t. All right, cool. And then we do the same thing for the other guy. So y squared equals 36 sine hyperbolic squared t. Now we're getting somewhere. So if we just subtract these two things, then we should have basically the identity. So if I were to say 36 cosine hyperbolic t, right, minus 36 sine hyperbolic squared t, well, that would be equal to x squared minus y squared. So x squared minus y squared. I'm trying to color code here so you can see how I set it up. So then you have this, and on the left side here, we basically have 1. And I'll go ahead and factor it out, but you don't really need to. Basically, if I were to factor out the 36, it would be cosine hyperbolic squared t minus, almost wrote 36, minus sine hyperbolic squared t. And that is equal to 1. We already know that's equal to 1, which is also equal to x squared minus y squared. So then this is just 36, right? That's just 1. 1 times any number is that number. And we have this. Now, from here, they want y equals. But before I do that, I'm actually going to branch off to the side here and divide everything by 36. You can see this is a hyperbolic function. This would be the hyperbola equation. This hyperbola equation would look like this, and so if I was to graph this, I would go 6 spaces in the x and the y direction, so it would look something like this maybe. All right, so it'd be kind of a square as my guideline. And since x is first and x is positive, that means it opens to the left and to the right. So it's going to look something like this, with asymptotes that go like that. And there's our equation. Now, the part that we actually have and we're actually dealing with is not the whole thing, though, because we have x is equal to negative 6 cosine, which means we're only dealing with this part. And I know that because you either deal with the left side or the right side when you go back to the original equation. Because if I were to do plus or minus, if it was plus or minus 6 cosine hyperbolic t, then I would be dealing with the whole thing, but I'm not. I'm only dealing with the left-hand side. But they want y equals, so if they want y equals, well, let's get y by itself. Let's subtract x squared on both sides. That would be 36 minus x squared equals negative y squared. Let's keep things positive here. Let's change the sign on everything. And then we would take the square root of both sides. And of course, when you do that, you get a plus or minus. So this is our actual equation. And that's what we would type into the blank there, is the square root of x squared minus 36. Which you don't need to try to factor. You can factor it, but it's not going to help you to simplify that radical at all, so there's no point. So that's what you would type in for the answer for this one. But it's really cool because the whole reason why we have hyperbolic sine and cosine is because it's based on, well, a hyperbola. So when we do this, when we say x and y are equal to cosine and sine hyperbolics, what we're saying is we're creating a hyperbolic function, a hyperbola. So it's actually really cool how that kind of worked out there. All right. So that's the answer to this question. I don't know and remember what question or where this is from, but if this is on your homework, you're welcome. And this has been Mr. Kyle, Myers Mathematics, and I'll see you in another episode really soon.